This is lesson 34, Proportions and Ratio World Problems. This is course 3. What we're going to be reviewing are proportions. Proportion is a statement where two ratios are equal. So let's look at my first example here. If I look at these two fractions, 2/5 and 10/25, if I multiply my first one times the number to get my second one, and that number is the same for the top and the bottom, it will then be a proportion. So what times 2 will give me 10? That's what I want to think in my head. And I know that 2 times 5 gives me 10, and 5 times 5 gives me 25. So I want to make sure that both of those numbers are the same, and because they are the same, this is a proportion. If they are not the same, they're not a proportion. Also, you could divide. You could say 10 divided by what gives me 2, and 25 divided by what gives me 5. And then again, both of those numbers are going to be 5. Another way to do them would be to multiply down. So 2 times 3 gives me 6, and 5 times 3 gives me 15. So when these numbers here are the same, this is also a proportion. We also know another way, it'd be a third way, to determining if this is a proportion. If I multiply these diagonal and my solutions are the same, so 6 times 5 gives me 30, and 2 times 15 also gives me 30. I know that those are equal, so those are a proportion. And I'm sorry for my bad penmanship. I do not have my pen today. So bear with me. Make sure if you have questions about anything that you ask. So we have 3 different ways to be able to tell if two ratios are equal, to be able to tell if they are proportions. So let's take a look at another proportion, and we want to be able to tell if this is a proportional relationship. So we need to know if they have the same values being multiplied or divided to see if they are proportion. I'm going to look across and say, okay, 2 times what gives me 12, and I know that that is 6. 6 times what gives me 35. Well, I know 6 times 6 gives me 36, so those across cannot be used. Let's look down. Down, I have 2 times what gives me 6. I'm going to say 3. 2 times 3. And 12 times what gives me 35. I know that 12 times 3 gives me 36, but nothing is going to give me 35. So either way, those are not a proportion. So this is going to not be a proportion. Alright, so then let's look below at our next example. And we're going to make a table with this just so we can determine if these are going to be equal. So Fred is paid $8 per hour. Is his pay proportional to the hours that he works? So let's just say he worked 1 hour. So the money he gets paid per hour is $8 per hour. So his pay per hour is going to be $8 per 1 hour. And so that's what we're going to leave that one out. So if he works 2 hours, I know that he's going to work 8 hours per hour, but he worked 2 hours, so it's going to be $16. So his pay per hour is going to be $16 per 2 hours. And if I reduce that, I'm going to divide that by 2, I'm going to get $8 per hour. So I can see here, even after his first 2 hours, his proportion, these two proportions right here, 8 over 1 and 8 over 1 are the same, so this is going to be a proportion. Let's look at another real-world example. So Nilsson has a paper route. If he works by himself, the job takes 60 minutes. If he splits the route with a friend, it takes 30 minutes. If 2 friends help, the job takes 20 minutes. Is the amount of time it takes to complete the route proportional to the number of people working? So we're going to do the same type of thing. So the first thing, if Nilsson has his route by himself, so 1 worker, it took him 60 minutes to complete it. And the time would be 60 over 1. The next one, him and 1 other friend, so 2 friends, or 2 people work the route. It took them 30 minutes. And so my time is going to be 30 over 2, which then that can be reduced to 15 over 1. Then he has 2 friends help. So if he has 2 friends plus himself, there's 3 people working. It took them 20 minutes. 20 minutes. So this time it's going to be time over the amount of people. So I have 20 over 3. And can I reduce this? No, because 3 is a prime number. So my ratio here is 20 over 3. So I have to be able to determine if 2 friends help, the job takes 20 minutes, is the amount of time it takes to complete the route proportional to the number of people working. So is it going to be proportional each time that he adds another person? Is it going to take the same amount of time off? So I'm going to set up all my proportions. So I have 60 over 1, 30 over 2, and 20 over 3. And I'm going to set these all equal to each other. And if I look here, I can say that if I divide my first one by 2, it's going to get me this one, my second one. So I can divide, let's use a different color, divide by 2. I can also divide by 2. But if I look from my second to my third one, I don't have anything that's going to multiply or divide on the same as the top and the bottom to make that one proportional. So my first 2 are proportional, but after he continues adding more people after that, those are not going to be proportional. So this is not proportional. And let's look at one more example. So we're going to use ratio real-world problems again. This time we're going to use a ratio box. And it's going to show like this below. So if our problem is, if the boys to girls ratio is 10 to 5, if there are 100 boys in the class, how many girls are there? So I need to know my ratio. And I need to know my actual. So my ratio, boys to girls, I know I have 10 boys for every 5 girls. And in my actual number, it says I have 100 boys. So if I have 100 boys, I need to know how many girls. So I'm going to set an X there, and I'm going to determine my ratio. So what times 10 gives me 100? Many of you will look at that right away and go, that's times 10. And so I have to take the top and the bottom times the same number to make it a proportion. So if I take 5 times 10, that's going to give me 50. 100 over 50. So my X value is going to be 50. If you have any questions about ratios and proportions and real-world problems, please make sure you ask in class.